Hello everyone, and welcome to OneClass. My name is Jeff Krause. I have a PhD in physical chemistry, and today I'm going to run through a few undergraduate high school level chemistry questions. So here's our first one. So it reads, the 4 bonds of carbon tetrachloride are polar, but the molecule is nonpolar because the bond polarity is cancelled by the symmetric tetrahedral shape. So just to draw this out, right, so we've got where I'm using this wedge to show that it's coming out of the page, and this dashed bond to show that it's going into the page. And so the idea here is we've got each of these dipoles set up, but because the molecule is completely symmetric, each dipole cancels, and so it differs a bit the way it's drawn between physics and chemistry, and I don't actually remember which way I default to, but I put the positive end at the plus and the negative end at the arrow, so my dipoles are pointing, I think it must be the chemistry way because it's pointing from positive to negative, which is the opposite to the definition of dipole, but that's fine as long as it's consistent. So as you can see, all the dipoles point out, but then they would all cancel. Okay. Okay, so now when symmetry is broken, we're going to get a dipole, and it wants us to rank several molecules. So I'm just going to draw them out as I come to them. So I've got C, H, bromine, and bromine. And I'm just going to draw a bunch of them. And of course there's other stuff down here. Okay. Okay, so CF2, CL2, C, that's supposed to be a wedge shape, F, Cl, and I'm not putting any atoms in any particular position for any reason. I'm just doing it based on wherever I decide to add it. And it shouldn't matter. For the answer, it won't matter where they go, as it shouldn't, because the molecule is symmetric, so if you rotate it, well, these ones won't be symmetric, but if you rotate it, you should be able to get to any orientation. Okay, where am I here? There we go. I'm just going to keep adding and erasing this stuff. Okay, that was that. So C, H, Cl2, and now CBr4. And CF2Br2. Okay. CF2. Oops. Should be Br2. Got carried away. All right, there you go. Now, okay, so now it wants us to rank these molecules from least polar to most polar. So to do that, we need to consider what each bond's polarity is and how it's going to add up in the molecule. So if we're looking for polarity, we're really looking for either electronegativity or electron withdrawing strength. So if you look at a periodic table, it basically increases from bottom left to top right. So that means that fluorine is going to be greater than chlorine, which is going to be greater than bromine, which is going to be greater than carbon, which is going to be greater than hydrogen. Okay, so then our dipoles are going to, at least in this, in my definition of drawing it from positive to negative, we're going to get dipoles set up in this molecule like this, as it's going to point towards if I'm pointing towards the more negative end, it's going to be towards carbon and CH bonds, towards bromine in the carbon-bromine bonds. This guy is going to point towards each of the halogens. So here we've got this pointing towards each of these. This is going to point now towards the carbons and towards the halogens. This one's going to point towards each of these bromines. And then this one is again going to point towards each of the halogens. Okay, so now we're drawing on some dipoles. Now, if we look at this ordering here, so a CF bond is going to be more polar than a CCl bond, which is going to be more polar than a C bromine bond. And the carbon-hydrogen bonds, if we look at, say, this molecule here, it's actually going to add up the dipole. So it's our carbon-bromines are trying to draw the electron density towards the bromines, and the hydrogens are just going to help that. So this is going to actually just increase our dipole. So all the hydrogen ones, so this one, and this one are obviously going to be our highest ones. And looking at this ordering, it's going to go fluorine higher than chlorine, higher than bromine. So we can start to rank here. So C2F2 is going to be greater than C2Cl2, which is going to be greater than C2Br. I missed some hydrogens in there. I'm just gonna erase it and start over again. So I started off badly. So CH2 F2 is going to be greater than CH2Cl2 is going to be greater than CH2 Br2. So our dipole is going to kind of run in that order, at least for the hydrogen-containing ones. Okay, so now we're left with three molecules, these three here. Now they both contain fluorine and another halogen. If we look at the directions, these are canceling, right? So we've got some cancellation, right? So the carbon-chlorine dipole is higher than the carbon-bromine. So in this case, we've actually got more cancellation due to the chlorines as compared with the bromines, right? Because the bromine dipole is less. And so that means that this guy should be higher because the bromine's dipole is smaller. So then that's greater than CF2Br2, which is greater than CF2Cl2, right? And so the fluorine-containing species with the bromine is going to be higher than the chlorine just because of smaller cancellations. And then if we look at this guy, we've got complete cancellation because it's symmetric again, so this dipole is 0, right? So then that's going to be our smallest, CBr4. And so then that's going to be our ordering. And now if we check through here, so for all carbon-hydrogen bonds, so for all carbon-halogen bonds, it's going to go in the order of electronegativity, so fluorine, chlorine, bromine. And then hydrogen is just going to build it up. So, and CBr4 is nonpolar because it's symmetric. So the ordering is just from smaller to higher here, whereas I did it from highest to lowest. So CBr4 is less than CF2Cl2, is less than CF2Br2, is less than CH2Br2, is less than CH2Cl2, is less than CH2F2. Okay, so that's our highest, and so the ordering looks the same to me. And so I'd say the solution is correct. Okay.